A very good evening, dear all participants of the day 2 online mode AICTE ATAL FDP on the topic A Bulwark to Neoteric Engineering. This ATAL FDP is a hybrid mode which is split into online mode from December 19th to December 24th and offline mode from December 26th to December 30th. It is a very fortunate to have both online and offline mode for this sessions. And for the today's online topic, I invite Dr. R. Arivagan sir, Associate Professor, Department of Civil Engineering from Meenakshi Sundarajan Engineering College, to present a title on the topic The Influence of Soil Grains Characteristics in Their Engineering Behavior. Before we proceed into the topic, let me give a short overview of the session today. The first part of the session will be till 7:50 p.m., followed by it a 10-minute break till 8 p.m., and the part 2 of the session will commence from 8 p.m. to 8:50 p.m. At the end of the session, the attendance cum feedback link will be posted in the chat box, and followed by it the QA in a short manner. Before we proceed to the topic, let me introduce a short brief note about our speaker today. So let me screen share the PPT. A short brief note about our speaker today, Dr. R. Arivaran, Associate Professor, Meenakshi Sundarajan Engineering College. Is a popular teacher and teaches basic engineering and science to students and encourage them for high studies and research activities. Sir did his BSc in Mathematics from St. Xavier's College, Palayam Gote. His engineering degree is from Civil Engineering, Institution of Engineers India, and the Institution of Engineering and Technology, London. His MTech is specialized in Coastal Zone Management from College of Engineering, Guindy, Anna University. Sir completed his PhD from the Division of Soil Mechanics and Foundation Engineering, College of Engineering, Guindy, Anna University. He has actively participated in organizing several short courses, workshops, FDPs, and national international conferences. He has delivered invited lectures at several workshops, seminars, and conferences. He has delivered guest lecture and faculty development programs conducted by various renowned colleges and universities. And also, his lectures are in various subjects for students from reputed colleges and universities. He is highly enthusiastic about his teaching and has handled many subjects in the UG curriculum. He has published 8 papers in national and international journals. He has presented 10 papers in the conferences. He is serving as an expert member in various universities. He is also a reviewer for the international journal Technical Gazette. His enriched knowledge in the field of civil engineering has given way to be a visiting professor at CEJ, Anna University, Institute of Irrigation Management, Tiruchi, Anna University of Management, Chennai. He is an active member of the Institution of Engineers, India, and the Institution of Engineering and Technology, London. His life fellowship is in Indian Geotechnical Society. So, with this short note, I introduce our chief guest of the day, the speaker, to present a topic The influence of soil grains characteristics in their engineering behavior. Thank you, sir, and thank you, participants.
Okay, thank you, Saravanan. It is audible, Saravanan. Is it okay?
Yes, sir.
Sound.
Audible.
Saravanan, it is okay. My
Yes, sir. The voice is audible.
voice audible. Can I ask this? Share the screen, Saravanan?
Yes, sir.
Yes. Sound. Okay, Saravanan, my audio is audible or slide? Can you see your slide?
Yes, sir. I can see the slide and also the audio is audible.
Okay, very good.
We
Okay,
can
very
go in
good.
the slideshow mode. So now, sir.
Yes, yes. So, good evening to all. Respected our Secretary Madam. She only my mentor and inspiration. Madam support me in all aspects. I am very proud to say that I am studied in this campus and worked in this same campus. Most respected our principal and my dearest friend Dr. P.K. Suresh and dear Dean HOD and my friend Dr. D.L. Ramadhyam and my colleagues, especially my team members Saravanan, Ravi, Dr. Easwari and Dr. Konni, my dear affectionate students, most important persons as our participants from various institutions. Good evening to all. On this moment, I like to thank my teacher and my well-wisher Raman sir. I am very sorry to say that most intelligent, dynamic personality, Professor Sachidanandam, was passed away, and he is no more today. He is passed away for nearly 1 month before. This is a great loss to me. He only gave a beautiful term of this FDP, Boulevard to New Geotechnical Engineering, for this FDPA. Yesterday, from Sir Krishna Reddy, very much appreciated this name. So at this moment, I say my gratefulness to Dr. Sachidanandam. I pray God for his soul to be rest. I thank all the participants to attend this FDP. Most of the participants are known to me. Dr. Dhanasegar, Dr. Logeshwari, Dr. Balraman, Pradipha from Kovai, Rekha Madam, Kariswaran, and many others. I can't mention all of the names here. Once again, I welcome you all. Happy good evening. So this is my topic. Today my topic presentation and my topic is the influence of soil grain characteristics in their engineering behavior. I am purposely yes, I am purposely selected this topic for this FTP because of the mixed specialization participants. So this study was based on three different areas such as geology, geotechnical engineering, and environmental and coastal engineering. All these three areas are connected together with a simple mathematical frame. That's why I put it M. In the intersection, I put it M. So the simple mathematics connect these three topics. So in this study, the soil grains, the topic I put the term soil grains. Soil grains means here I mean for the sand particles. Sand is a natural material available in different size, shape in different environmental situations like river bed, ocean bed, and seashore, river bed, and so many areas. It is available in different sizes, different colors, and different forms. The sand particles are formed from the parent rock and deposited in different composition of sizes. So, in the reverse way, from the sand sizes and their distribution, we are going to identify what are the deposition system, what are the environmental system, and environmental subsystem. So this is the objective of this study. I think I hope you can understand this one. I am going to take a sample, sand sample placed in any environmental system. So I going to analyze the size and shape and how much the grain size distribution. From there, I'm using some mathematical formulas and mathematical theories. I'm going to find out this what is the environment it belongs to. So what are the different types of environmental system? How it will be the origin of the environmental system, like that we are going to see in this presentation. So the main character of this presentation is a sand. This is sand, the most common constituent of sand in inland continental and also on the non-tropical coastal settings. It is called as a silica SiO2. It's a common name is sand. It is mostly available in the form of the quartz. So now it depends upon the sand sizes. The sand can be named in different way. Different people are having a different types of classification. This is one type of classification that is called a van der Waals size class, the van der Waals classification. So depends upon the size, the sand can be classified as pebbles, gravel, very coarse sand, medium sand, and fine sand. Then silt also we can classify it as a coarse sand, medium silt, and fine silt. Then another one is clay. Then another one is organic content and there are some residues. So according to the van der Waals scale, 2 to 0.06 mm is classified as a sand. Then below 0.06 mm, it is classified as a silt. But in the same pi scale, the pi, this is another scale, van der Waals scale. This is mm scale. This pi scale is not in mm. So what is pi scale? That is very important in this
So one
study.
small query, sir.
In this study,
Sir,
so I will explain this on the next slide. So this is a pi scale.
sir, am I
This is a
audible, sir? Hello, sir.
Napa,
Sir,
Arvind,
slideshow full screen learn easy இருக்கும்.
slide so
Slideshow mode full screen F5 learn easy இருக்கும்.
F file வைக்கவா wait F file F file full
Yes,
screen
sir.
இருக்கா sorry for disturbance. So this is a chromium pi scale. The previously it is a van der Waals size classes here. So 0.06 mm up to 0.06 mm is a very fine sand, and below that it is classified as a silt. So it's another one, the Peruvian pi scale. It is another modified scale of the van der Waals scale. But this scale is very easy to analyze the soil grain characteristics because this is a law. This is a pi is equal to minus log 2 d by d naught, where pi is a Peruvian pi scale. The d is the diameter of the particle or grain size in millimeter. D naught is a reference diameter is the particle that is we consider as reference as 1 mm. So if you put the diameter, whether it is a 75 micron or 2 mm or 0.425 micron, whatever it is, whether silt or coarse silt or fine silt, whatever it is, you can get the full number, not fraction, you can get a full number. So that is the main advantage of this Peruvian scale. But you can read in different way. Then I can show this one, all this one in the another slide. This is another type of soil classification. So here the sand particle is classified as up to 0.06 mm, 0.06 mm. Then clay is 0.02 mm. The difference is in the van der Waals scale up to 0.004. Silt here 0.002. There is a small difference in this one. So in this classification, you can see and below that this method of analysis, the sand particle. This is a dry sieve analysis. That is up to sand particle we can analyze by using the dry sieve method, sieve analysis. Then below the 75 micron is classified as a silt. The grain size distribution of the grain silt can be Analyzed by the laboratory method is called hydrometer analysis. It's a wet analysis. So this is a comparison of the Vanderwerth and pi Kimbrian scale. So here you can see that, for example, here the silt is 0.074 mm here. See here, this is 0.074 mm. This is a silt. That is called 74 micron, 75 micron. But in the pi scale, it is classified as 3.75. It is a dimensionless. This dimensionless is going on decreasing, going on decreasing. Therefore, up to certain limit, we can't say, we can call it is in a millimeter. We can designate it as a micron. So 0.074, we can't say 0.074 mm. We can call it as a 74 micron. This is a difficulty in the Vanderwerth scale. So up to fine sand, we can call it a mm. Then after that, we can denote it as a micron. But in the pi scale, the convenient is in the full number. Well, see now here, that is 2.5, 3.25, 3.75, 4 like that. So the only the difficulty is we have to familiarize with this pi scale. Then it will be easy. Here the rate will be increased. The rate will be increased. See here minus value is going on increasing. The 4 silt, fine silt, here 4.75, 5 mm. It is increases, but the size is less. Pi size is less. There is a little confusion. If you are familiar with this pi scale, it is easy to understand. That is the only drawback in this one. Next one. This is our study area. Study area, that is a beach. A beach. What is beach? Everybody knows it is a landform alongside of a body of water which consists of loose particles. So based on the color and the minerals, the sands are classified in different names. So the beaches are named in different ways, depends upon the sand particles deposited in the beach. So these are very beautiful pictures. It shows that is a pebbles. The sand particles are in the form of pebbles in the California beach. That is a single. It is a North America. That is a these particles are gravel. It's a California. The very beautiful picture shows different types of sand. In biological also, the ecosystem also, the beach is varying, depends upon the plantation and it depends upon the ecosystem. Beach can be classified as, this is a mangrove forest of Pichavaram, Tamil Nadu. Then this is a coral reefs. These are all shallow marine. This is shallow water. The salinity also less. Here also salinity also less. That one we are seeing the 4 or 5 slides. I can explain different types of environments. Now I want to explain the different types of beaches. Depends upon the size of the particle. Depends upon the color of the sediments deposited and the types of plants and ecosystems in the beaches. That is a Casnora plantation. This we can see in the ECR beaches, ECR East Coast Road. We can see this type of Casnora plantation. We can call this a sensitive ecosystem. Sensitive ecosystem is a soft measures to protect the core. For protect the core, we can construct as like a YENU, we can construct a crayons or breakwaters and sea walls like that. That are called hard measures. These are natural system, ecosystem is protect the coast. It's a 2004 tsunami, the mangroves are very much protect the coast. Here this is a coral. This is also in the shallow marine. These are called a very sensitive ecosystem in the Gulf of Mannar, Rameswaram. In Andaman is abundantly available. It's a Casnora plantation. It is also soft measure to prevent the erosion and all. That is a sea shell beach. We can, if you see in the Pulicat estuary, you can see this type of sea shell beach in our Chennai itself. These are based on the color. See the very beautiful picture. It's got a pink sand. The color is a quartz only, but the sand is in the color of pink. Then is another one is a green beach, green color sediments. Then here fine white sand. So nobody will believe. So therefore I am particularly I put the name of the beach also. Name of the beach also. If you went to the Google, you can search this type of sand beach sand. Very nice beaches. That's in Australia. That is a yellow color. It is Spain. Then Adut is a black sand. This is look like a black sand. It is not polluted. The natural color is itself is a black. That is a red sand. Red sand here. Red sand from is Then there are orange color sand beach of Malta, then gray sand is the North Sea. So beach, the sediment, the major constituent of the sediment is a sand particle. So it may be a coarse sand or medium sand or fine size sand. It's also in different shape, different colors, like that. Yeah. So this is some now we enter into the engineering behavior, engineering property. Here the term it will crimes is permeability is a very important term. Important term. The permeability, if you know what is meant by permeability, there are two terms you have to understand. The one is called intrusion, another one is inundation. That is the movement of water towards the land process is called intrusion, another one is called inundation. That is what is the meaning of these two terms means the movement of seawater towards land side have two processes. There one is called intrusion, another one is inundation. Intrusion is the process of seawater moving underground into the areas of fresh water in an aquifer where water is present. So it's a below ground level. This process is below ground level. Inundation means above ground level, top of the ground. That is, it is overland flooding of seawater that happens during by storms, tides, and due to sea level rise. Due to sea level rise, that is called inundation. So here, the two process we have. So when the permeability this being acquired is if swash infiltration is significant, the water that infiltrates will not participate in the backwash. So this term I will explain later. What is the swash and what is infiltration, what is the backwash, I will in the next two or three slides. There is some literature they talk about the permeability behavior. Swash infiltration depends on the permeability of the sediments, right? Which increases with the grain size and the surface. This is our main character of this presentation. That's a grain size. So the grain size increases, the swash infiltration also the influences. In coarse sand beaches where swash infiltration is very important, the beach slopes tends to increase with the permeability. Here, this is the picture. It's a self-explanatory picture. You just to see this picture, you can understand the what the beach system. That is an intercontinental shelf that is more than 30-meter depth. We are not interested now. Our interested area now is the beach system and morphology. Morphology. That is first one is called near shore. Near shore that is 1 to 30 meter. So 1 to 30-meter height. 1 to 30-meter height. Then it is called wave soiling. This is called this process wave soiling. Wave soiling. What is a wave soiling means? The changing shape and behavior of the waves propagate into water of decreasing depth. Waves are generated here. Waves are generated here. It moves towards the land side. It changes the shape and behavior of wave, propagate into water of a decreasing depth. This is called shallow water. Going on decreasing. The depth of the water is going on decreasing. So here waves are generated. It changes the shape and the size. It approaches the land side. Then at one time what happens? The wave dissipate, the energy will be dissipate. The energy is reduced. The wave will break here. The wave will break here. Again it moves towards the land. Then it is called the swash. That is a very important term that we saw in the previous slide. The swash means a flow of water up the beach after wave has broken. This is before wave break. Then after wave break, it becomes a swash. So this swash only creates a inundation and intrusion. This water may flow over the land or sometimes it may be passes through. This is called a permeability. So the permeability depends upon the grain size, whether it is about coarse or fine sand, medium sand. Depends upon the sand size only the permeability will influence. Then after that, this is a surf zone. What is a surf zone? Surf zone is this one. Surf zone is an ocean surface waves approaches the shore, they get taller and break, forming the foaming, bubbly surface called surf. This region is called surf zone. This one we are all very familiar. This is what is surf zone. So after the wave break, the waves move towards the land side. Then after that backwash. Backwash again it come back to this portion. This is called a surf zone. Then these are the some characters of the destructive wave. So this is here the waves are formed here. So it forms a circular orbit. It's circular orbit. It going moving towards the land side. Then after that, this orbit becomes a elliptical. This elliptical shape because of due friction, so in the base of the wave. So again, after the wave break, it moved towards the land side. That is a surf zone. Then after that, what happened? Some permeability, due to permeability, the water will enter into the soil mass, or due to inundation, the water will be moving upward. Then after that, the energy dissipates, the wave comes back again. That is called, that is a backwash. That is called, this is a backwash. That is a weak swash. It is a backwash. So what happened? This is very important in the sediment deposit process. So during backwash, what happens? It depends upon the energy. So sometimes because due to some energy, here the sand particles are deposited here. Sand particle means I already in the soil classification I explained. Sand is not a single unique sizes. It consists of different sizes. So we can classify into coarse sand, fine sand, and medium size sand. So all are different sizes. Three categories we have. So during that, what happened during the backwash, the energy is more or energy is less. So what happened when it returns back, it brings some particles towards them. So sometimes the water, sometimes the weak swash deposited the sand particles here. Sometimes during the backwash, some particle may be returned back along with the water. Here it deposited here. So it depends upon the energy level. Depends upon the energy level. In some beaches, coarse sand is deposited. Sometimes medium sand will be dominant, or fine sand will be dominant, or it will be in equal proportion. Different size of proportions they are available. Depends upon the wave energy. This is one of the sediment deposit is causes of the sediment deposit. There are different causes are there. This is one of the causes. This is the one of the causes. So we will see, we'll see the next slide. So in this presentation, these are some simple basic methodology, selection of location, selection, selection of location on shore line, then the sample collection, then laboratory investigation. Laboratory investigation in geotechnical laboratory, I'm going to analyze the sample, analyze. Analysis, then specific gravity test, then some index properties we are going to find out in the laboratory after collection of the sample. Then the main thing is statistical parameters. I will explain the next slide. So from this one, I'm going to find out going to analyze the coastal morphology, the energy enrollment, depositional enrollment, then how what is the mode of sediment transport, how the sediments are transported from one point to some other point. Then next slide. Ah, then I expect further detail. These are statistical parameters means I follow the folk and what. It is framed in 1957. It's a very old, but till we can use this one. It's a best tool to understand the depositional system and environmental system. That is the statistical parameters. I am take so many parameters are there. I am selecting some few parameters by by using the folk and what equation. That is mean, standard deviation, known as kurtosis. Then based on these statistical parameters, we are going to analyze the beach slope. That's called a morphology. Sometimes some area we can tell the steep slope, gentle slope. So there's some shallow water, sometimes the water will be deep in the very the beginning itself, the very sea water will be in very deep. So this is called a coastal morphology. Then energy enrollment, how the wave energy is increases or decreases. Then where the energy in the wave will be break. Where is the surf zone? What is the distance of surf zone? What is the length of the shallow marine? These are called coastal morphology. So for understand this coastal morphology, energy system, depositional system, so I'm going to use a mathematical tool by using the statistical parameters. That is one number one is called bivariant plots. Then another second one is called linear LDF. That's called linear decrement function. Then another one is CM diagram. So these are three major tools I'm going to use in this study. By using the statistical parameters, mean, standard deviation, skewness, cutoff list. These for these four parameters, I am going to use the theory of fork and walk. Fork and walk. So this bivariate plot, LDF and CM diagram. From this concept, I'm going to analyze the what is a postal process, what is a depositional environment, and what is the mode of sediment transport. So before that, I will explain what is mean by postal process, what is mean by postal morphology, then what is a depositional environment, then what is the mode of sediment transport. Then I will explain first. Then after that, I will explain how what is mean by bivariate plot, what is LDF, what is CM diagram, then what is the objective of the study. We will explain later. So this is a study area. This is study area. So I am taking 10 along the east coast. On the east coast, I am taking 10 samples. 10 samples. Then the first one is called Chennai Port Trust. Then Thiruvanmiyur Beach. Then Ejambakam, Kovalam, Soar Temple, Veyur Kupam, Kalpakam, Sadarangapattinam, or it is known as a Satrust. Then Mandavi, then Auroville. That is up to Pondicherry. Chennai to Pondicherry. I am taking different locations. Every is a location having different features, different uniqueness. Chennai Port is well known, that is a Chennai Port. Then after that, the Thiruvanmiyur Beach and Ejambakam are used for residential plots, resorts, and tourism activities are there. Kovalam is also a residential and tourism activity. Then Soar Temple, that is a very important location in this ECR. That is another one is Meyur Kupam. Meyur Kupam, that is one Dutch fort is there. Then Kalpakam. Kalpakam is famous for the AICTE, Indira Gandhi thermal power station. We started Meyur Kupam. Meyur Kupam are Satters, we have a Dutch fort is there. Then most of the area is covered by Cashinero plantation. Then Auroville Beach is also a tourist spot and a residential community. So here the major one is Chennai Port. Chennai Port is a very important point here. It is a very eroded area, the Ennur and also well vulnerable to erosion and all. Then the next critical area is a Soar Temple. Then next it is called Sattras and Kalpakam. So three critical areas. Then I am selecting these three critical areas. Then only we can compare the vulnerability and different types of postal process compared with the other areas. Therefore, I am taking 10 samples. So here more critical area is called a Soar Temple. See, a Soar Temple is situated near Mahabalipuram. Mahabalipuram, it is a 7th century, 8th century. It is created by Pallavas. Pallavas in the 7th and 8th century. You can see the very beautiful Soar Temple. Soar Temple. So adjacent to the Soar Temple is a sea wall. It's a hard measure. This is a soft measure to protect the coast. This sea wall is a hard measure. We are man-made. We are putting stone. So why we are putting this stone here? It's a very beautiful temple is here. It's a UNESCO's heritage site. Now it becomes a UNESCO heritage site. So that much beautiful area we are considering like that because of this is very vulnerable to erosion. How we can say it is a vulnerable to earthquake? Vulnerable to erosion in 7th and 8th century. Pallavas built seven temples in this area. That is are well known. It is called as a seven pagodas. So at present we have only one temple is there. Only one temple is there. Then what all other temples are taken by sea. So that in 2004 tsunami, before struck up the 2004 tsunami, the water go back, that is receded to 500 meters towards the sea. So at that time, the residents at the Mahabalipuram and the tourists witnessed and they said they saw the long wall, narrow wall and brick work in the sea there emerged from the sea water. That is a evidence that prove that in that period they are constructed seven pagodas, that is six temples are placed there. Then after tsunami wave approaches, after tsunami wave approaches to sea, then all are sunk inside the sea water. That is the evidence of that. Therefore, we are preserve this temple for our future generation. Therefore, we are constructing the seawall here to prevent the erosion. So now it is the vulnerability is a decrease, but at the same time we are constructing the seawall, we protect the solar temple here, but it will give the impact on this Kovalam, this is the south side of the solar temple and the north side of the solar temple, it gives an impact of that. So that things are all we are going to study in this study area. in this study. The next slide. This is our students. Our students take a sample and all. These are our students. Uh, he is Mr. Kannan, the assistant executive here at PWD. He will be giving support to logistics, taking samples of the coast. It's a very beautiful picture here. It is not only a beach, not only beach, you can see it's a beach here, there is a jetties here. This here one sea one wall sea wall here. Then other side one sea wall is here. It is not a sea wall. It is a crayons that constructed by PWD with the help of the IIT Coastal Engineering Department. They construct here. They construct crayons here. So to prevent the, it is north side of the first site area that started Chennai Port Trust. So the Ennur highway is very much vulnerable to the erosion for the longer period. They can't construct the highway also. It's very difficult. There are so many factories also in that area. It is very much affected by the erosion. So at that time, the PWD decided to prevent the erosion at that area. Therefore, they constructed. So, but the fisher community opposes that because it will affect the fishing activity and all. So they construct the crayons on that side. It is nearly 500 meters one crayons were constructed. Then what happened? It is giving a very good result, very good result. The erosion is prevented, but at the same time, it is giving a double impact, double of the benefit. So the beach is formed. Previously, it is eroded. Here the sand is taken away by the sea wave. Then after constructing the crayons, the beach is formed here. Very beautiful beach is formed here. That is the advantage of constructing the crayons on the east coast near port. So the next slide here, I designate the sample here. Here I designated as S1. So each 10 there are we have 10 locations. Then each locations I collect a sample in 3 places. That one is at the back shore, then another one is foreshore, then another one is a berm. Berm is a beach. Here is a beach. The back shore and the foreshore are designated based on the low tide and high tide. So this portion I can mean as a foreshore. This is a back shore. This is in between we can get a berm. Therefore, we are collecting samples from these 3 locations. 1, 2, 3 locations. Like that, 10 samples, 10 locations. So 10 into 3, 30 samples are collected. Then after collecting the sample, we are doing a laboratory investigation. That was the first test is sieve analysis. So specific gravity test is followed by the IS code, the IS 2720, Part 3, September 1980. Then yeah, in that we are found that sand is a 2 point, is a very important data 2.2. So among the 30 samples, all samples are not having 2.2 specificity. Some places specificity is higher than that. Some places specificity is less than 2.2. So we are going to interpret that result why the specificity is reduced or why the specificity is more than the normal value. Then after 4 or 5 slides, I can explain what is the interpretation of this value. Then the another one, the dry sieve analysis done by IS 27020 part 4 1985. Then direct shear test was also performed here in this test. I found out the value of C and by the sand sample, then C that is automatically 0. Then I found the angle of intersection pi value. Pi value is also not constant for all the 10 examples. It will differ. So we are going to find out why the angle of intersection is varying in different locations. What is the causes for that? Like that also we are going to study. So this is a test result. This is a test result. The tracks test result. That is in one graph itself, we draw all the 10 locations. But I divided into 3 categories. One, the first graph shows all 10 locations for back shore alone. This is all 10 locations, the berm alone. Here, the foreshore alone, but all 10 samples. So here itself, we can, there's a very self-explanatory graph, this one. In all these, the curves are not coinciding with each other. See here, no one is coinciding with each other. No one is coinciding. All are different. Some are very close, some are very far away, but nothing will be coinciding with each other. It shows every location have distinct grain size distribution and different deposit. So from this we can understand the wave is so much dynamic, It's not uniform everywhere. So this is a grand size distribution curve. So every location among 30 locations, each every location having their grand size distribution is different. So what is the grand size distribution means? Some fine sand is dominant. Some places moderate, medium size sand is will be dominant. Some place coarse sand will be dominant. In some sizes, three sand particles are equally placed in that. Someone is fine sand is dominant, medium size sand is very less. So like the different combination is there. So from this prices distribution, we are going to identify what is the causes of this, why is this much variation, or why this is dominant. So like that we are going to understand or identify the depositional environmental system. So the test results are, I can classify for a better understanding. I classified the total sample like this. See, this is a very interesting graph. This is called this curve is the triangle is called a ternary diagram. Ternary diagram is very useful to understand the concept here. This is coarse sand. This one is a coarse sand. This is a medium sand. So one sample we can have a three sand sizes. It is not a two x-axis, y-axis. We have a three components: coarse sand, fine sand, and a medium sand. So each sample is having different components. Then how can we identify? That one I can classify like that. A1 means slightly medium size and fine sand. Here there is no coarse sand. A2 means slightly coarse sand and fine sand. Here also no medium size sand. B1 very medium size and fine sand. Here there is no coarse sand. Then slightly medium size sand, fine sand. Here also no coarse sand. So like that. Here extremely coarse sand, slightly fine sand. Here no medium size sand. So like that in deep, very micro level, we are classifying the samples. You will see how much it is. Nearly 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Nearly 24 classification we have. That much minute study we are did here. So these all one can be represented in a very good diagram. This is called a ternary diagram. See here, suppose if you are taking this one, this is A1, this is A1. So A1 means this is a fine sand. Fine sand is here 25%. Fine sand is 25% here. 5 to 25% fine sand. Then here, this is not fine sand here. See here, this is 0 to 5. 0 to 5, then 5 to 25, 25 to 50 fine sand, 50 to 75 fine sand, 75 to 95, 95 until 5. These are the maximum fine sand. This is 100% fine sand. So here, see here, one sample having 75 to now 95% fine sand. So therefore, this is coming under this category A1 or A2. Then this one A1, this one having only this much area, this much area. So all samples are having, see here, 75 to 95. This person is having 50 to 75 fine sand. This person is called 25 to 50. This one is called 5 to 25. So all are fine sand dominant only. So this is a very good diagram explaining the grind size distribution. These are the values. I put it in the table column. So from that I find out the CC value, CU value, then D5, D16, D25, D50. These values are calculated from the grind distribution curve. That is what is the D50 means. The 50% of the samples are what is the size. That is 0.2. 70% of the samples are cumulative. These are below that 0.2. That is 0.293. Then, as told in the previous slide, I converted all into pi scale. The same. So one sample I am putting like that. S1, S1, S1 like that. So like that for all the 10 samples, I find out the D5 to D99 values. So why I am find out the D5, D16, D20 means I am going to follow the Fokan plot equation, mathematical equation. In that mathematical equation is a function of these values D5, D16, D25. The statistical parameters, mean, median, skewness, curvature that we can find out. We are going to find out that are all in terms of these values. That is pi 5, pi 6, pi 25. Therefore, because of that find out the mean, median, deviation curvature. I convert the T5, T6 value into Krumbian scale. So these are the statistical parameters. statistical parameters: mean, mode, median, standard deviation, skewness, kurtosis. I will explain what is mean, mode, all things very few slides. I'm not going to go in detail. This is very simple pictorial representation of the mean, median, kurtosis. So, as we are familiar in the mechanics, we know that mechanic moment means force in the distance. Distance means the distance between the line of action of the force to the distance where we are going to take moment. We can call it a moment. So, it's the same way we are following the statistics. That is called mean. This is a mean chord. That is the first moment. Then the second moment is called standard deviation. Third moment is known as skewness. Then fourth moment is known as kurtosis. So like that way, we are calculating the mean, standard deviation, skewness, kurtosis. But in this study, I am not going to follow this methodology. I am going to follow the fork and word method. So I will explain the formula later. This is a very good graph. So in the same graph, I will plot all the values. See here, this is all the 10 samples. 10 samples. I found the four statistical parameters: mean, standard deviation, kurtosis, skewness. I staked all the graph in one side here, one by one. It's called R Pro. R Pro is one special software. So we are plot this one. Yeah. This was very much useful to interpret the mean statistical parameter values for our study. This one first one is a mean. Mean is a central value. Mean already we know that is mean is a central value. This is a formula. This is a formula for calculating the mean value. That is the Broke and word formula. That is 560, 550, 584. So using this formula, I can find out the mean value. Mean value is called a central value of the finite set of numbers. Finite set of is a central value. The sum of values divided by number of values. We have known that. It is called as a law of large numbers. What is the law of large number? The average of the results obtained from a large number of trials to be close to the mean. But mean is not necessarily the median, same as the middle value. It is not as a mode. That is, mode means appears most often is a set of values. So it is a central value of the finite set of numbers. That is a simple definition of mean. So by using the fork and word formula, I found out the mean value for all the samples for 10 locations, all samples. Then I classified as 1.911. So this S1, that is batch source. That is the port. First location is for N port. In that batch source, the sand is classified as a medium size sand. Medium size sand is dominant here. Then Berg medium size sand. F1 medium size sand. So here the total sediment is medium size. All are coming medium size. But you see in the second sample in batch source medium size. Then worm and foresource fine sand is there. Fine sand is there. So here the grain size itself varies. In the three locations itself it varies. Then another sample batch foresource. Three places having different sizes of sand. These are all due to the energy, wave energy. It depends upon the energy only the deposit system is varying. Then here, the mean size indicates the central tendency or the average size of the sediment, and in terms of energy, it indicates the average kinetic energy or velocity of deposit. This is how 1954. They give a beautiful explanation about the mean. So in our location, the range of mean size, the batch source, see here, this is a minimum value 0.94, maximum value is 2.145. So 0.94 increases means this is considering this small value. It is a higher value, 0.664 to 2.155, 154, 0.94 to 2.14. This is itself varying. See, it is not uniform for all the locations. Minimum value is 0.9, maximum value is 2.14. But if the berm, it is different. That is 0.664 and is 2.154. Then foresource 0.940, 2.145. Like that. This is a summary of the mean value results. Then I divided into three categories: 1, 2, 3, 4, like that. So among the 10 samples, Chennai port, Chennai port, Sadras, the Aravalli beach. These are having similar. These are having similar. That is a fine to port side. See the process. Fines to port side. Then another one, these four samples, Thiruvani Beach, Indapakam, Kovalam, Niyur, Kuppam, they are forced to fine, forced to fine, forced to medium, from back shore to foreshore. This is very important observation here. Back shore to foreshore. Foreshore, near, then berm, then back shore. So back shore, fine sand is there. Then foreshore is this is variation. But here, back shore coarser sand, here fine sand. Here coarser medium. But these three sand locations, fine sand is dominant. Yes, this is medium size is dominant. This is coarse size is dominant. Then what it means? Fine sand is dominant means among 100%, more than 75% fine sand is available. More than full sediment, medium size should be more than 75-80%. The coarse sand is dominant. So what the significance of this one is less variance in the grain size shows low wave energy environment. Low wave energy environment. It indicates because the full sediment is fine sand. Here full sediment is medium. Medium sediment is coarse sand. So it is having the constant wave energy, constant wave energy. The swash is come from the wave where it goes and it touches the land side. Again the backwash is not creating much influence. So it is fully dominant, but here not like that. The wave energy is a turbulent. It creates fine. It is a force. So what happens? It brings the force sand towards the sea and during the backwash. In this place, what happens? The wave leave the coastal sand in the back shore, remove the fine sand, deposit it in the coastal side. Here, coastal sand is leave the coastal sand on the back side to bring the medium sand along with the wave deposited in the coastal side. So it will clearly explains the wave energy system. Then let's see here next one. The sediment pressure in the beach are influenced by wave energy. In the low energy environment, sediment deposit is influenced by wind activity. Wind activity is also major impact. Not only wave energy, window energy. So this one we will see later. Then fine sand sediment dominant means sediment transported by suspension. These are also mode of transport. I will explain this in the future after 4 or 5 slides. Then medium and coastal dominant, what is its significance means? Wave energy, already I told, wave energy removes the fine sand and it leaves the medium or coarse sand due to higher energy of the wave. And coarse sediment dominant. Suppose any beach, the coarse sediment dominant means that the beach should be certainly steep slope. Certainly steep slope. The next one is a standard deviation.